Hello student, welcome to Power Electronics. This is Raid Al-Malki. Inshallah today I'm going to explain lecture number 5. Now, lecture number 5 is talking about three-phase, full-wave, uncontrolled rectifier. Again, I'm going to explain this title for you. As you can see here, we are talking about rectifier, and this is the last topic for the uncontrolled rectifier. Now, again, rectifier is just only, it is type of converter which converts from AC signals into DC signals. So when we are going to rectify something, signals, so we are converting from AC into DC. Now, why we say the uncontrolled? Because we use diodes again, okay? And diodes, we cannot control alpha in diodes. That's why it is uncontrolled. And we will see, inshallah, after the midterm, we will go again the same topics, but with the controlled rectifier. Okay, now why it is full wave? Full wave because we are using 6 diodes. We are using 6 diodes. We are opening the path for the negative part to come to the supply, negative part of the waveform for the 3-phase supply in order to have more ripple, and then inshallah we will have more output power. Okay, so inshallah today we will see introduction about the 3-phase full wave and controlled rectifier, and then we will see some examples and revision examples also. Now, this is our, if you can see here, shabab, this is our circuit. Okay, now in this circuit we have again 3-phase, 3-wire supply. This is very important, shabab. Now, 3-phase, when I say 3 wires, I mean there is no neutral. There is no neutral. Neutral is not there. Khalas, no longer. It was in 3-phase half-wave rectifier. Here we don't have the neutral because we are using the negative part of the waveform is going again to the supply through the phases, not through the neutral. Okay. That's why we are using 3-phase, 3-wire AC supply. Okay. Now, this is phase A. This is phase B. This is phase C, right? Now, this is diode number 1. This is diode number 3. This is diode number 5. And here we have diode number 4, diode number 6, diode number 2. Now, someone can ask me why it is organized like the numbers here, D1, D3, D5, and here D2, D6, D4. Now in our circuit here, it is the names of the diodes are organized based on the sequence. Okay, the sequence of the waveform. Now let's suppose that we have the voltage A, so it will go through D1, it will go to the load, and then it will come here to the supply. Okay, that's why D1 and then D2. That's why we have here D1, here we have D2, because it is according to the sequence. Inshallah, I'm going to explain everything, don't worry. This is just to show you why do we have this sequence, D1, D3, D5, and so on. You will see it, inshallah, through the explanations, inshallah. Now, okay, this is our load, of course. This is our load. Here we have voltage DC, voltage output DC, right? We have here plus, minus. Here we have load. In this case, we have resistive load. In this case, we have resistive load. Now, we can conclude from this circuit, rectification circuit, that we have 3 diodes here for the positive cycle, 3 diodes here for the negative cycle. Now we call those 3 diodes, we call them positive positive diodes or positive group. Okay, here we can call them negative group of diodes. Now, how the diodes are working, when D1 is conducting, when D2 is conducting, when D3, and so on, we will see inshallah how to group them. We will see the waveform, how they are acting. Now, please read this paragraph in order to understand more about the three-phase and why we don't have neutral in this circuit. Now, as you can see in the right side of our slide here, this is the full wave three-phase uncontrolled rectifier formulas. Now, in order to find V out DC, then we can apply this formula, which is 3 V maximum line to line divided by pi, line to line divided by pi, right? Now, you remember in three-phase half-wave rectifier, it was 3 root 3 V maximum line to neutral divided by 2 pi. Now, why do we have here pi? Now, you remember also we said that here we should have 3 for 3 diodes, right? 3 for 3 diodes. Now we have 6. I'm going to change the color. Now we have 6, right? Should be 6, right? This is 6. And also we have here line to line, because this is a three-phase. We don't have neutral here. We don't have neutral. It should be line to line, right? And also, if we have line to line, then we shouldn't have row 3, because V maximum line to line is equal to what? Row 3 V phase, or V line to neutral. V maximum line to neutral. Okay, that's why. So we remove this term by this term. Okay, and then it should be like this: 6 V maximum line to line. Then it is divided. Allahu Akbar. This is divided by 2 pi. Okay, now if we divide 6 by 2 here, so 2 will go, and the remaining is 3 V maximum line to line divided by pi. So it is the same as this formula, right? Okay, so make sure that you know this formula. This is very important. And V maximum line to line is equal to what? Row 3 V maximum line to neutral. And the rest of the formulas should be driven from Ohm's law, so it is easy. I out DC is equal to V out DC divided by R, and so on. Okay. In the coming slide, inshallah, we will see how the diodes are working, inshallah. Now let's go to the next slide. Now let us see our rectification circuit here on the left side. Okay, this is our rectification circuit for the three-phase full wave uncontrolled rectifier. Now, as you can see here, we have 3-phase, right? 3-wire AC supply. Now, in this circuit, we don't have neutral. Neutral, it should be with this 3-phase half-wave rectifier. Now, in this circuit, we don't have neutral line because we don't need it. That's why we have 6 diodes. And in 6 diodes here, shabab, we allow the negative part of our supply. Before, it was like this. This is our supply. This is diode number 1. This is diode number 2. And this is diode number 3. Right? 3 of them is going to the load. And it comes back through the neutral. Now we allow the negative parts. That's why you have 6 diodes. Then there is no need for the negative part. Okay? Now, as you can see, VA or phase A is connected to D1 from the anode and D4 from the cathode. Phase B is connected here between D3 and D6. VC or phase C is connected here between D5 and D2. So in three-phase full-wave rectifier, we have 6 diodes. We have 6 diodes in order to rectify the circuit from AC into V out DC through or across the load. Okay, now you can notice something here. We have 3 diodes up here and 3 diodes down here. Now we can control, we can say and that those 3 diodes are called positive group. Okay, or we can say positive diodes. Here we can say that they are negative group. Negative group. Now why I say that? Because those 3 diodes are working in the positive cycle. In the positive cycle. Now let us see. Let us see. I'm going to erase يا شباب. Now let us say that this is phase A and it is in the positive cycle now. It is in the positive cycle only. Now if the charge here is positive and here, as you can see from D1, we have positive and negative. Positive because of the anode, negative because of the cathode. Then if they are having the same charge here, then it will be forward bias and it will conduct, the diode is going to conduct, right? So it will allow the current to move. So D1 and D3 and D5 are conducting when the positive cycle is there. Okay? Now let us do the same thing for the lower diodes here. I'm going to use another color. Now let us assume that for D4 we have now the negative cycle of VA, right? Because VA is connected here. So either D1 or D4. So through the negative cycle, here we have positive from the diode, right? And here as the charge we have negative, and here we have negative, here we have positive. So the current will go from here because this one will be forward bias and it will allow the current to move through the load and come back to the supply. Okay, so D5, D4, D6 and D2 are working when the negative of the supply is there. Negative of the supply is there. This is very important to understand. So those those diodes are positive group. Those diodes are called negative group of the diodes. Okay. Now let us see how the diodes are working. Now here in the waveform يا شباب, here in the waveform we can notice that we have 3 phase, which is phase A, right? This is phase A. It will start from 0 as a reference. Let us assume it will start from the reference and it will finish at 2 pi, right? From 0 to 2 pi. This is one cycle. We know that one cycle يا شباب, as explained in the previous lectures, one cycle should be through period time, which is the period, and one cycle we can say period is equal to 1 over frequency, and frequency again is equal to number of cycles per second. Okay, number of cycles per second. And as you know, we have one cycle here. The one cycle is defined as it will start from 0 and end 2 pi. This is one cycle. So it will start from here, from 0 up to the maximum, and then it will finish here, right? So this is one cycle. So 1 divided by 1, so it is the time of the period is 1 second. Okay, now this is phase A. Now this is phase B, right? To start after 120, as we explained before, this is the same as the half-wave rectifier. Okay, to start after 120. Okay, and for phase C, it will start after 240 from phase A. So this is our third phase. Okay, now this is for the three phase. Now let us see our waveform and analyze this waveform, شباب. Now, as you can see here, phase A, let us see the waveform from 30 degrees up to 150 degree. 150 degree. Now, in order to have D1 is working, we should know something very important. Okay, in order to D1 to conduct, we should know that VA must be bigger than VB and VC. So VA should be bigger than VB and VC, same as the half-wave rectifier, the half-wave three-phase half-wave rectifier. So in this period, in this period, we can see that now VA is bigger than VB and VC, right? So D1 is going to be conducting. So this is D1. So D1 is here. Okay. Now for D2, for D3, we should say that because it is connected here, right? So it's connected here. We should know that D3, it will conduct when VB is bigger than VA and VC. So from this period, from 150 up to 270, VB is bigger. VB is bigger, right? So we can say that D3 is going to conduct in this period. Now, for D5, okay, now we are talking about the positive cycle, right, Shabab? For D5, it is connected here, the VC, so we should know it will conduct when VC is bigger than VA and VB. So we can analyze from this circuit that VC is bigger, okay, so the complete of the one cycle is here, Shabab, huh? This is also VC. So this is D5. Okay. Now I'm going to complete here. Forget about this line now, because I'm going to explain very important thing. So sorry. Yeah. Now I'm going to use another color. We can use the black color. So this is VC, right? This is VC. So D5 is going to conduct at this time. Now this is for the positive cycle. Now let us see the negative cycle here. Now for the negative cycle, here the supply VA, it should be bigger in the negative side, or we can say it is the lowest of VB and VC, the lowest value. Now please identify in the waveform where is VA is less than VB and VC. Okay, and we can decide. Now VA is less than VB and VC, D4 is going to conduct. So as you can see, this is VA, right? So it will, this is the lowest value of VA. So VA now is less than VB and VC, and we can say it is bigger than VA, VB and VC in the negative side. So either is correct, okay? Now let us just say that VA should be less than VB and VC. So this is VA here يا شباب, it should be less than VB and VC. So in this period, and we can say this is D4. This is D4. Okay. Now for D6, okay, for D6 we will use the green color. Now for D6, in order to have D6 is conducting, we need VB, right? VB is less than VA and VC. Where is VB? This is VB. This is when the VB is less than VA and VC. So we can say this is the conduction of the angle of the D6. Okay. Now for the last one, okay, we'll use the blue color. For D2, right, VC should be less than VB and VA, and here we have VC is less than VA and VB, and this is D2. So as a conclusion from this diagram or this graph, or this waveform, is that we have 6 diodes. We have 6 diodes. Each time, each 120 degree for the positive diodes, one of them is working. شباب? So one of the positive cycle here, شباب, the positive group, it should work, okay, with one of the negative group. Okay, if D1 is working, شباب, if D1 is working, then D6 should work, and so on. So one of them is working here, it should be working with one of them is here. Okay. Also, we can say this is D6. Now, let me do it here. The same concept, شباب. Same concept, and here also the same. This is D6. Okay, and also for the D2. No. This is D6. Sorry, this is D6. Sorry, شباب. This is D6, because D6 is working with what, شباب? With the VB, right? So with the yellow one. So this is D6, right? This is D6. D6. And here we have for D5 or D2 is here. This is D. This is D2. If you are going to complete one cycle, this is one cycle. Okay, this is one cycle. Okay, so this is one cycle. Now, as you can see here, we have 3 diodes working for the positive cycle, 3 diodes working for the negative cycle. Now, let us divide our waveform into what? Into into 60 degree, and let us see 60 degree. Okay, شباب. Now let us see. This is our first 60-degree, right? From this side. Okay, from here up to 90, from 30 to 90. Now from 30 to 90, we can see here that D1 is conducting, right? And D6 is conducting. Okay, Shabab? So we have two dyes, D1 and D6. Okay? And as you can see, if D1, it should be connected with VA, right? So if it is connected like this, now let me just erase to make it clear. Shabab, focus here. So as we said, in this period between 30 and 90, D1 is conducting and D6 is conducting. So D1 is connected here to VA, D6 is connected here to VB, right? So VA, the voltage and the current is going through D1. So D1 is working and it will go through the load. It will come back to D6 and D6 should work, okay? And then it will go to VB. So now we have between phase A and phase B, right? So here we have phase A, here we have phase B. So the potential difference between the two voltage should be a line voltage, right? So it should be VAB, right? That's why in this period, we have VAB, VAB. Clear? It should be clear, okay? This is for the first two diodes, okay? Now let me erase. Now let us see the second two, or the second 60 degree, okay? The second 60 degree. Now the second 60 degree is between 90 and what? And 180, 90 and 180. And as again, we have this part, Shabab, is for D1 and this part is for D2. Now, let us see here, Shabab, where is D1? It should work with D1 and D2, right? So D1 is here, right? D2, it should be here, right? So the voltage or the current is going through D1, through the load, and to go to D2, and it will go again to VC, okay? Now the voltage is between VA and VC. So here should be VA because it's from the positive side of the load. Here we have VC. So the voltage difference between VA and VC, the phases, it should be V line, right? So it should be V line AC. This is VA line VAC. Again for the third one. Again for the I'm going to do it for the third one, Shabab. And the rest is the same. Okay. Now this is the third one. It's good to practice, Shabab. Now for the third angle, it should be from 180, right, up to what? 150. 150 plus 60, it should be 210, right? So between this, in this period, D3 is working, right? And D2 is working. D3 and D2 is working, okay? So D3 and D2. Okay, this is where is D3? D3 is for the positive, the 3, and D2 is for the negative part. Now let us see. Now it will go from here through D3. Of course, it will be forward bias, right? It will go through the load, and through D2, it will come back to VC. Now the voltage difference is between VB as a positive and VC as a negative. So it should be VBC. That's why we have BC here. Okay? Let me complete it for you, Shabab Ahsan. Now, I'm going to erase. Now let us see in in the next cycle, the next 60 degree, from here up to 270, from 210 and up to 270. D3 is working, D4 now is working, okay, as the negative part. So we say D3, right? Okay, and D4. This is D4. So it will go from VB through the load. It will come back to D4 and then to the supply. So the voltage now, VB is the positive, right? So it should be VB here, right? It will come back to VA, so VA is here. So our voltage line voltage is, now this is phase voltage. This is phase voltage. Now our line voltage is VBA. This is VBA, شباب. This is VBA. Okay. Now this is VBA. Okay, excellent. Now let's go to the second one. Now again, for this period, for this period, until from 270 until 330, we should have D5 and D4, D5 and D4, D5 as a positive, D4 as the negative. So it will start from here through D5, from the positive side of the load. It will come here, it will go through D4 to the supply. So we have here as a positive, we have VC, here we have VA. So therefore the difference between them is VCA. So this is VCA. Now this is very important, shabab. This is very important. Now in this part, shabab, let me erase this one. Okay. Now this is very important. Now in this part, after 330, we need to have 60 degree, right? But 60 degree, it will reach to 360. From 330, we should add plus 60, right? صح ولا يا شباب? So we have until 360, we have 30 degrees. صح يا شباب؟ وال 30 degree اللي هنا اللي موجودة, this is the 30 degree from the beginning. So this is D5. This is D5. Okay. Now, so in this period, we have 5, and we have what? We have 6 also. We have 5, we have 6. D5, this is D5, and this is D6. So it will go from VC up to the load through VB, and it will through D6 to VB, right? So we have VC, here we have VB. So the difference between them, between VC and VB, it should be V line to line, which is VCP. So this is VCB. So it will start from here up to here, right? Because this is the up to 360. So this is 360. Okay, and the complete of this part is here, Rishabh. Complete this part is the beginning of our waveform. Okay, so if I choose, if I write the number of the dies, so in VAB we have diode 6 and 1. Here we have 1 and 2. Here we have 2 and 3. Here we have 3 and 4. Here we have 4 and 5. Here we have 5, 6. Here also 5, 6. So this is the repetition of the waves, and this is the output voltage V out DC. So this form is for the V out DC. This form is for the V source. Waveform is for the V source. Okay, so we can conclude something very important, that in three-phase full wave uncontrolled rectifier we have 6 diodes. 3 diodes here in the positive group are working in the positive side of the voltage source, and the 3 diodes here are working in the negative part of the voltage of the source. And the combination between 2 diodes, we can conclude that one diode from the positive side is connected with the one diode of the negative group. Okay, so one of them for the positive group يا شباب here, one of them should work. One of them it should work. For the negative side, one of them also it should work. For the diodes يا شباب, we know that as a waveform, 2 diodes should work at the same time, which is one of them in the positive cycle, one of them is in the negative cycle. Okay, like 6 1, 1 2, and so on, 2 3, and so on. Okay, so this is the 3-phase full wave uncontrolled rectifier. Please, if you do not understand something or anything here, please repeat the video until inshallah you understand everything inshallah. Now let us come here يا شباب. Please read this paragraph in order to understand very much about the 3-phase full wave uncontrolled rectifier. Now we can conclude something, that between the lines, the voltage of the lines, we have 60 degree between them. So each 2 diodes should conduct when we have 60 degree. Can you see we have 60 degree for each 2 diodes. Okay, now for VAB voltage line, V line, it should start with 0, and then 60 degree, then 120, because we are adding 60. VBA should start with 180. VCA should start with 240. While VCB, it should start with 300. Okay, so this is the sequence. Make sure you understand يا شباب. This is very important again. This is very important in the examples يا شباب. You'll see it inshallah. Now the V maximum line to line should equal to √3 V maximum line to neutral. This is from circuit 2 يا شباب. Okay, and in order to find the total current, or the total current which is I out, we should add ID1 plus ID2 plus ID3 and 3 multiply I out. 3 multiply I out. Okay, this is the output, the average output current. Now here, as I mentioned, in VAB we have the running diode is D6 and D1. For VAC, D1 and D2, and so on. Okay, what about the phase shift between them? D1 and D2, the phase shift is 300. D1 and D3 is 240. So the difference between them, okay, D1 and D6 is 60 degree, of course. Okay, so between line and then another line we have 60 degrees. Between the phase and other phase is 100 degree, as we know from the three-phase system. Please refer to notes pages 28 to 34 in order to understand and see the voltage of the diodes, each diode, and the current of each diode. You can see it in the waveform يا شباب. Also here يا شباب, you can refer to our to this video. This is from Ibrahim Saleh, Mr. Ibrahim Saleh. He's our teacher and he's teaching also power electronics. You can refer to his video in order to understand how to draw the three phase and how to see the output voltage and output three phase as source and output voltage as DC voltage. Okay, now this is just only to remind you how to draw. This is for we have here on the right side we have VA, VB, VC because we have three lines, right? So this is in this part we have 120 degree, 120 degree, we have D1, and this second that we have 120 degree also D3, and this is 120 degree, we have D5. And this part we have D6, D6, okay, and this part we have D2, and this part we have as we so this is how to draw and this is how to identify where is the diodes here, where is the diode are running. Okay, here we have D4. Yeah, this is for the three-phase full wave uncontrolled rectifier. Now again here from this 60 degree يا شباب, this is the 60 degree, we can identify that D1 and D6 are working together. That's why we have VAB. And again here we have between D1 and D2, so this is second one, and this is the output voltage for our three-phase full wave uncontrolled rectifier circuit. Okay, so this is the output voltage. This is how to draw the three-phase. Now in order to do it like this perfection of drawing, we need to do something very important, and he already mashallah explained very well here in this this video how to draw this graph. Okay, so we can just draw at each 60 degree, we can, this is 30, right? Now this is 90, each 60 degree we can, you should start from 30, and each 60 degree you can put point like this. Okay, and each 30 degree you can put at one of them is like this. Okay, and again 60 degree, and also again you can repeat the same thing here. So at the beginning you can start from 30 and you reach to 60. Okay, add 60 degree, add 60 degree, and so on, add 60 degree here, add 60 degree. Then in the upper side you just make space here for you can start from 60 degree and add 60, add 60, and so on. After that you can connect them together. You can see how the waveform is working. Now I explained this is this wave is roughly now. You can refer to this video in order to see it more clearly and you will understand how the waveform is being drawn. Okay, now let us go to the example. This is our example here. Okay, he said we have a three-phase full wave uncontrolled rectifier has a purely resistive load which is 10 ohm and 240 again voltage and 60 hertz power supply. Now this is line to line يا شباب, this is line to line. Make sure you understand this is line to line يا شباب. Okay, Now, the first thing he said, find the output ripple frequency. Output ripple frequency. Of course, we know that ripple frequency, FR, ripple frequency is equal to frequency of the supply multiply number of pulses. And we know that the frequency of supply here is 60. Multiply 6 pulses, of course, because we have 6 diodes. Then it will be, the answer will be 360 hertz. This is A. This is A. Now, for the average load current, he asked about the average load current. So when I say average load current, I mean output voltage DC, right? Output DC current. Output DC current. Now, for P, we know that V output DC is equal to 3 V maximum line to line divided by pi from here, right? From here. Now, how much V maximum? We know that if I give you a number like this without sine wave, it should be RMS value. Now, if I give you a number like this, 240 sine omega t. Now this number is V maximum. This is very important, shabab. I explained this in the introduction video. This is very important. If I give you like this form, here it should be V maximum. If I give you 240 like this only, without sine wave, without sine and omega t, it should be V RMS. Okay? Now, so this is V max. It needs V maximum. This is RMS value, right? So we can say it is 3 multiply root 2 multiply 240 divided by. So the answer is I'm not sure about the answer, but I think it is 314 or 324. I'm not sure. Okay, fault. Now check this answer, Isha. Check this answer. Okay? Maybe 324. Now, this is for the voltage. Now, we need to find the current, of course, because he asked about the current out, I out DC. It should be V out DC divided by R. So it's 324 divided by 10, which is 32.4 ampere. So this is the answer. Now, for C, he asked about the maximum diode current. The maximum diode current, again, the same as we have done in the half wave, 3-phase half wave and controlled rectifier. I maximum is equal to V maximum divided by R. Now V maximum is root 2 multiply 240 divided by 10, which is 339.4 divided by 10, which is 33.9 ampere. This is for C. Now for D. So, mashallah, if you understand part B, خلاص, everything is going smooth. Now, what about conduction angle? Conduction angle, is the gamma, which is 120 again degree. Now for E said the average load power, which is P out DC. We know from Ohm's law that I out DC multiplied by P out DC, and it is here also, so you can refer to it. Okay, and it is equal to 324 multiply by 32.4, which is equal to 10,497. I'm not sure about this number, shabab. So we can, this is what? Okay, check. Now, F, he said number of output pulses. Of course, we know it is 6 pulses. Okay. For the average diode current, G is average I output DC divided by 3. Sorry, 6, because we have 6 diodes. Then the answer is 5.4 ampere. Now this is how to find the diode current, average diode current, and this is for the 3-phase full wave uncontrolled rectifier. Now let me just only revise with you the one important example for the full wave single phase full wave rectifier, uncontrolled rectifier. I haven't given you this example, so I included with this lecture. Okay, he said a single phase full wave uncontrolled rectifier has a resistive load of 30 ohm, inductive load of 0.2 Henry, and it supplies from line to neutral. This is the form of the supply voltage. So it is 140 sine omega t. Omega is 176, and 140 is here, shabab, V maximum. V maximum, right? This is V maximum. Now, let us solve this question. Now we know, as we said, this is omega. So omega is 176. V maximum is 140. The resistor is 30. The inductor is 0.2 Henry. So in order to find the DC power delivered to the load, this is A, huh? So we need to find V output DC and I output DC. So V output DC is equal to V output DC from single phase, shabab. This is wrong, shabab. This is wrong. We should take it from single phase full wave. This is wrong, huh? This is for the 3-phase. Now, V output DC is 2 V maximum divided by pi, which is 2 multiply 140. So it is already V maximum divided by pi. So it should equal to 89 volt. Now I out DC is equal to V out DC again divided by R, which is 89 divided by 30. So it is 2.97 ampere. So for A, now power output DC is 89 multiply by 2.97 is equal to 264 watt. So this is for A, right? For B, he needs to find the current at D2. So I D2 diode number 2 is equal to I out DC, as simple as that يا شباب, divide by 2 because we have two diodes, right? So 2.97 divided by 2 is equal to 1.49 ampere. Now this is for P. For C, he said the ripple frequency. Find the ripple frequency if R is equal to, again, supply frequency multiplied by number of pulses. So it is supply frequency is omega. Now this is very important note يا شباب. We have omega now, we don't have frequency. So omega is the angular frequency, is the frequency in a circle. Okay شباب. So we know that omega is equal to 2 pi f because we are representing frequency in a circle يا شباب, in a circle, in this movement. Okay, so we are representing the frequency in a circle, so that's why we have 2 pi. Okay, so omega is equal to the angular okay frequency is equal to what? 2 pi f frequency. Now if you need to find f, so it is basically omega divided by 2 pi. So omega is 176 divided by 2 pi, which is equal to 28 hertz. So 28 hertz multiplied by number of pulses, we have 2. It should be 2 multiply 2 multiply 8 and so on. Okay, 54 hertz. This is our ripple frequency in this slide. Okay, thank you so much for attending this lecture and stay safe. Thank you so much. See you later.